Welcome back. Today we are going over binary search. So this is one of those algorithms I feel that you'll be using over and over again because it's the fastest and cleanest way to find something in a sorted list. So this algorithm will also show up constantly in interviews. So even when a problem doesn't literally say binary search, the second you see sorted or find or big O log n, this is usually what they're testing. It's pretty safe to say. So it's really important. You should know binary search like the back of your hand. You should be able to implement it in less than a minute for coding interviews. It's really important. So let's just get right into it. So the first thing to know, the key condition in binary search is that binary search only works on sorted data. Your data has to be sorted to use binary search. So that's the whole reason we can do something smarter than scanning through for like every element to find a target. So let's just say we have a sorted array like this we have right here. You can see it's sorted from least to greatest, ascending order. And let's say we want to find a target number like 7. Let's say 7. Instead of checking every value in the array, we keep a search window using 2 pointers. So we'll have a left pointer for the left side of the window and a right pointer for the right side. So left will be at the beginning, right will be placed at the end of the array here. So obviously left's at 0 and right would be at length of this array minus 1. So every step we do the same thing for every step. So we find the middle index, or m. So what is the middle index between these two? It's 6. This is the middle. And then we compare the middle with our target. So you can see our middle here is 6, and 7 is greater than 6. And that means, since the array is sorted, since 7 is greater than 6, that means it has to be on the right side of our array here, the right side. So then we can throw away this other half, the left half, that because it can't contain the target because it's sorted. It has to be on the right side, not the left side. The left side would be smaller numbers. So that's why this algorithm is pretty quick. So you would just loop through and keep going. So then now you have this half right here. And then you would just find the middle of this. The middle of this is 8. 8 is more than 7. That means it has to be on this side. It has to be on the left side now. Left side of the array. And it is. Now if you compare again the middle, you would get 7 and then you would find your target. So that's how binary search really works. I feel like I could explain this way better just through code itself. So let's just implement it in code. Let's just go over here. So we have binary search. This is just normal binary search. It's easy, Leetcode easy. So to start, we would set up our 2 pointers. So we have a left pointer and a right pointer. Let me just get that better. And then obviously our left pointer would start at the first element 0 and our right pointer starts at the end. So length of nums minus 1. And now after we define our 2 pointers, let's start looping through. So let's have while loop. While left is less than equal to the right pointer. So this loop means as long as there is still a valid range to search. So if we used less than instead of less than or equals to, we could skip checking the last remaining element. So that's why we do that. And now remember, in binary search, we need to find our middle. We have to calculate the midpoint. So usually a way to do this would just be originally, this is what everyone thinks best way is to do this. You just do the left pointer plus the right pointer and then just do floor division by 2. But we don't do this. It's not like in good practice, and the best practice is not to do this because this could cause overflow. So This is the standard safe form to use. So the standard safe form to use would be just the left pointer plus, then you have parentheses, and then you do the right subtracted by the left, and then you do floor division by 2. This would prevent overflow. So this is just the safe way to do it. So now after that, now that we've calculated our midpoint, now we want to compare. So this is where the conditionals come in. So if the middle, our middle right now, is more than the target, what does that mean? If the middle is too big, we have to throw away the right half and look at the left half. That means we need that means our target is a smaller number. So you have to look at the left half. So what does that mean? So we throw away the right half and we set our right pointer to the middle minus 1 because we already checked the middle. And that means we set our pointer to the left of the middle, the left side. And now let's have our else if. So now else if the num's at the middle, let's say it's actually smaller than the target this time. That means if the middle is too small, then we just throw away the left half now. So we would move our left pointer to M, the middle plus 1 to focus on the right half because our target is a bigger number. And then obviously otherwise in our else it matches, so we just return the index immediately. So return M, the middle. So finally at the end, obviously, let's say we don't find our target at all. Let's say the target number isn't even in the array. So if we exit the loop, that means the target doesn't exist in the array. We will just return -1 as it says here in the problem. So if we run this now, this should work. Yep. Test case is passed. Let's submit it. And there you go. That is binary search.